Hi, hello, good morning, everyone. Welcome everyone to Fit 5136 Software Engineering. And this is week 4 already. Time flies very fast, and I hope everyone enjoyed the unit so far. Previously, we talked about software engineering process, requirement analysis, how to model the software, that kind of thing, right? But this week we will delve into more detail about how to work as a team, how to deal with the conflict, that kind of thing within the teams, and what is the unified process and agile and version control system as well. Okay, so that's the basic overview so far. Let me take a look a little bit. Okay, yep. So we need to assign Yiwei as a co-host. Okay, yeah. And then all good. Yep, I will get started now. Okay, all right. So today, mainly there are 4 topics that we are going to talk about: working as a team, the unified process, agile, and the version control system. Easy peasy. Okay, so we'll try to fit everything within 2 hours. Okay, working as a team. So why do we need to do that, right? So in in real world scenarios, we need to work as a team anyway, and we cannot work individually. There are lots of things things out things in real world are quite complex, and there are it requires lots of expertise. For example, let's say in a software development team, we may not be an expert in everything, right? Sometimes we need like a requirement engineer expert, we need a tester expert, we need like a deployment expert. For example, the DevOps engineers, cyber security expert, or that kind of thing. So we need to work as a team, and a single person or single individual cannot be an expert in everything as well, right? I mean, in typical scenarios. So that's why teamwork is very, very important. And actually, it is part of the Engineer Australia Stage 1 competency as well. So basically, when we teach the student within the unit, how can we ensure that the student have a chance to work as a team within the group, that kind of thing as well. Okay. Yeah, and teamwork is also part of the Australian working culture as well. We cannot work alone at all. And as I mentioned before, software product is very large. We cannot like be a sole programmer or sole software engineer who develop just one single piece of software, right? So that's really impossible because there are lots of components that involve in the one piece of software. For example, the UI, the back end, the front end, the system. We need people who have expert, and then we need to work with them. But how to work with them effectively and efficiently, right? The challenge is that when we work as a team, people come from different backgrounds, right? How can we communicate with them? Okay, so yeah, at least, yep, okay. So for example, right, this is what I mentioned before. Yeah, this is a Conway's law. So basically, I will try to get the pen and notate here. 1 second. Yeah, Conway's law. This is very classic. So they said that the system being produced will tend to have a structure that mirrors the structure of the group that is producing it. Okay, so the key goal here is that whatever happened in the organization structure, it will be a mirror to the software products anyway. If we have like a clear organizational structure, the software products will be of high quality and it will be clear as well, right? Uh, and think about this one. So let's say this is a company structure, and then we have 4 stakeholders here, 4 people who involved in software development team. Okay, first is the business process. The second one is the UI. The third one is the back end, and the last one is the database. So that means, what does it mean here? When we because we have the this kind of people, right? The expertise here. That's why the structure of the software system will be is a reflection of the organizational structure. So that means when we talk about the software system, when we design the system, the business process will handle the business requirement. UI will just focus on the UI of the software system, right? Where the back end focus on the back end and the database will focus on the on the database. When we have a clear structure like this, then it, as I mentioned before, it will reflect how the software is designed, how the software is architect. And if we don't have like a clear organizational structure, the end products will be a little bit messy as well, and then it will not be clear, right? Okay, so this is called a Conway law, which is uh, which is like a it was created since 1968. Okay. Yeah. Okay. So when we work as a team, right? So there are different kinds of team. The first of all, the first one is that a kind of like a democratic team. Okay. And that's on the left side. So basically, we work. Everyone has an equal vote to work on something, right? But when we talk, and another kind of programming team or software development team is that chief programmer team. So we just follow what the boss asks, and probably it might not be ideal as well in real world scenarios, right? So that's kind of like a two extreme scenarios that everyone should decide which the direction that we should go. And probably, and personally, I would rather focus on the democratic team. Everyone has an equal work and with the equal vote and equal workload balance as well, and then everyone can have like a share. Is the team responsibility. We work together to create the valuable products, high quality products, right? Yeah. Okay. So there are different types of team. As I mentioned before, there are democratic team, chief programming, and the last four, it will be the modern programming team. We will talk about that. What does it mean? Extreme programming team, the Scrum style, and the open source software team as well, right? Okay, so let's start with the flux question here. So let's say you have a team of five people, right? The person A, B, C, D, E, and when a person A working on 10 features, okay, on feature 10, things a new input parameter is needed, and person B finds a fault in feature 10, okay? So person A work on the feature 10 and they think that a new input parameter is needed, and the person B find some bug in the feature 10, and the person C did some original design in the feature 10, okay? Person C do the design. And person A goes on leave without changing anything about this feature. So what should the team do? All right, that's a complicated story. Okay, so go to the flux question here. Okay, maybe put the link in the Zoom chat. Yeah. Yeah, I'll go back to this slide. Okay, scenarios. What should they do? Yeah, so we got a few response here, right? And Yeah, that's right. So a few suggestions that they make a lot of sense. For example, they should work together. They should communicate with each other, right? And probably a meeting is required to sync to ensure that everyone is on the same page. But let's try to analyze this one together. From what I'm thinking is that person A developed this feature, right? So they find that the input parameter is needed. So probably A is the dev software engineers. B find the bug. Probably this guy is the QA. Okay, QA. And original design, C did the original design for the feature 10. So probably this is a requirement or the design person. Okay, the software architect. And the person A go on leave without changing anything about the feature 10. Okay. Um, yeah, so I think right now let's try to analyze it, right? There are a few issues here. First of all, uh, the team is quite like they don't have like a backup person, right? When someone goes on leave, and then no one can come back and like fix some things, okay? So this happens in most of the software companies as well. That's it's called the turnover issues. Let's say we have a team and one day software engineers just want to go on leave or they are fired. Then who is the next person who is going to like uh, fill this role, right? So there are a couple of things that we can do. Okay, first, for example, documentation, right? If we have a clear documentation, then everyone is on the same page. We have like clear design guideline, what we should do, what should be implemented, where it is, which component are they. Okay, there's a documentation is the first thing. Second, I would say that code review might be helpful here as well. When people code review is like a pair, not pair programming, but I mean, if someone develops something, if this person review whether the code is correct or not, that kind of thing, right? So they learn as well what did they do, that kind of thing. If this person is gone, then this guy, the person B may be able to come back and help some other people as well. Okay, so I think in this case, okay, documentation might help, code review might help. Of course, definitely meeting might help as well. Communication, okay, that we also need it. Probably project management tools, issue tracking system is also needed as well. So we are on the same page, like where are we at the moment, okay, and what is the remaining tasks, that kind of thing. Okay. Mm-hmm. Yep. Okay. All right. So team issues. Yeah. Most of the time, right, when we have issues like the previous scenarios, it means that they don't understand with each other. There's no standard tracking tool. They are not on the same page. And different people have their own personal circumstance as well. Probably they may have some personal issues or that kind of thing. And what we should do is that we should have empathy. We should like understand each other. uh, yeah, let's try to talk about it and think about it. How can we resolve such kind of the team issues? Okay, yeah. Uh, Okay, first of all, normally what is that here? When we work as a team, we distribute the task equally, right? And the good thing is that we can shorter the time to market. We can release the products quicker, and we can increase the quality of the software system as well. We can work effectively. Everyone has equal work. Is a team responsibility, share equal load together, right? But but the main issue here is that it's about the communication among the team. That's the key point here, right? um, when we don't communicate really well, it impacts the productivities of the team member. They may not understand like what are they doing, and whether they work on the same thing or not, or the work is redundant or not, right? And which one should work first, which one should work the last. So that's about the prioritization. It's more like the project management. Okay, so there are lots of team issues that could happen as well. Okay, and because different people come from different backgrounds, they may have different cultures. We may need to understand like their own context as well, like what is their personality, what works well with them, what is their communication style. Even let's say that what is the best or preferred communication channel, right? Someone prefer SMS, okay, text messaging. Someone prefer Slack, someone prefer on the other tool, right? So different people have different preference, but I think the key point here is that how can we compromise and work together as a team effectively, right, and efficiently as well. Yeah. Yeah, and there are other issues as well about the team issues, right? For example, they don't have motivation, or I just want to pass the unit. I don't want to get any HD, or someone has some personal issues. For example, due to the COVID-19 crisis, I have some financial hardship impact my mental health, that kind of thing. So this kind of thing, this is more like a personal issues. We should try to separate between the professional working environment and the personal issues, right? When we work, we should work professionally, work with your friends, work with your teammates professionally. But when we but any personal issues, it should not like cross the boundary. It should not go to the professional setting at all. And what does it mean by work professionally? Okay, for example, attend the meeting, be active on the emails, communicate like with respect, be respectful, understand, be a good listening, active listening skill, that kind of thing, you know. So these are the things that we need to work out and work and ensure that there's no such team conflicts. All right. Yeah, and in general, it is possible that different people have different opinions, right? So that means when to deal with such kind of conflicts, probably we should try to focus on what is the goal. Yeah, why do we need that, and what are the reasons behind, right? So then try to discuss, calm down, no avoid such kind of high voice or argument or that kind of thing, you know. No ego. Okay, different opinions is fine. Okay, it's about the discussion and communication, whether how to resolve such kind of conflict. Okay, and there are a few things that we suggest here. Okay, first of all, try to get to know each other. Yeah, play some game probably. That might be helpful. Then know how to socialize with your teammates. Okay, and try to sync with each other as well. Check with them whether they are doing well or not. How do they feel? How do you feel? That kind of thing. Yeah, and when someone express some opinions, probably it is best to for you to acknowledge their opinion as well. For example, oh yeah, that's a great idea, but I think that if we do this way, it might be something blah 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 blah, right? So it's about the language and how can we communicate with each other politely and respectfully as well. Okay, avoid, do not let the team split into the sub team. Okay, we should don't do like that. But if you have any issues, try to consult with your mentor as well, or you can send us an email to the role account fit5136.clayton-x@monash.edu. If you have any team issues, this is just some a guideline. All right, I would say that we don't want to see any team issues. Okay, we don't want to deal with that. But if something worse happen, try to reach out to us as soon as possible, and we'll try to see whether what we can help. Okay, and make sure that it is not too late as well. Okay, and in the Zoom chat, if you have some if you need some mental health support, right? Monash University also have like a counseling program as well. So yeah, please feel free to join that if you have such kind of thing. Okay. But this is normal. Don't to worry about that. Okay, so the next question. If you have a conflict in a team, what should be your first step towards resolving the conflict? Okay. Okay, that's right. Thank you. Okay. Yeah, so as I mentioned before, conflict, different opinions. This is normal. It happens all the time, right? But what we should maintain is the professionalism. We should avoid any inappropriate behavior, any rude comments, any discriminate actions, that kind of thing, right? Or any harassment, we should avoid that. And yeah, so I mean, I don't know. I'm a nice person, so I'm not into this one that much. So what I want to say here is that yeah, we should avoid the inappropriate behaviors, and Monash has a policy, for example, harassment, that kind of thing, right? Don't threatening the tutors or that kind of thing as well. And this is one of the cases as well. For example, the University of Melbourne accused of ignoring female students allegedly harassed in class. So there are different kinds of harassment here. For example, telling the insulting jokes. We want to avoid any insulting at all. And yeah, that kind of thing, right? So we should avoid this kind of inappropriate behavior. Yeah. At all right. Okay, I found some very useful video here, how to work as a team. Okay, let's try to look at it together. 1 second.
While collaboration is more than...
Okay, does everyone hear the sound?
While collaboration is more than just working together, the skills involved in successful teamwork are important to successful collaboration. It's important to be a good team player. Every organization's success relies on effective teams, and modern teams are often made up of a diverse mix of individuals and circumstances. They may be cross-functional or multidisciplinary. They may be co-located or collaborate remotely. They may be made up of familiar coworkers or complete strangers. There may be cultural or language barriers to overcome in order to work together successfully. But regardless of the team situation, the basic principles of being a good team member apply. In almost everything you read about being a good team member, there are the same lists of basic qualities, such as being honest, fair, respectful, reliable, responsible, and a good communicator. But there's more to being an outstanding team member, qualities that don't always get the proper attention. A good work team member shows genuine commitment. There's a tangible difference between someone who shows up to work on a team and someone who is genuinely committed to the team's goals. If you're committed, you're in the office when needed, and you make sure that your seat time is worth it by contributing as much as possible while you're there. The best team members get involved. It does not serve you well to just sit quietly and do your work in a silo. Don't stay in the shadows. Instead, get involved with your team. If you don't know something, find out by asking team members questions. Strong team players come to their teammates prepared with their questions and ideas clearly thought through. Solid team members need to be transparent. Sharing opinions and ideas is important as long as they don't actually belong to someone else. You don't have to take credit for everything. In fact, giving credit for ideas you're sharing earns you respect and trust. As an outstanding team worker, you must be ready to help, even if it's not in your job description. Be generous with pointers or tips to help your team members. For example, if a member is experiencing frustration when using a new technology that you're experienced with, offer your help and share what you know. Along those lines, successful team members work to be problem solvers, not problem makers. Help resolve problems even if they aren't directly yours. If a teammate is stuck with a problem she's working on, take the initiative and try to solve it or at least help. This earns you respect and is sure to come back at you someday in a positive way. When you have a problem in the future, it may be you on the receiving end, especially if people remember how you've given of your time before. And as a good teammate, recognize and acknowledge when you're wrong. The point is to work hard and be good at what you do, not try to be right all the time. Being stubborn is not a quality of a good team player. Team members respect you when you admit you're wrong, or when you back off an idea when it's clear it's not the right path. If you strongly believe that your team is making a mistake, you can usually find a way to come back to the issue when the time is right. And if it happens that you were correct, accept it gracefully. These, of course, are hardly the only characteristics of good team members, but they provide a solid starting point for successful collaboration. They are a blueprint for beginning the work of successfully working together with others.
All right. Thank you. That's cool. We learned something. Okay, how to work as a team.
The Navy SEALs are one of the highest performing organizations on the planet, and a former Navy SEAL was asked.
Okay, I will move on. Now we will talk about there are different types of the team, right? As we mentioned before, like a democratic team style, working style, or like a bossy style, or that kind of thing. But this is more like a more real world scenarios now. Extreme programming team. What does it mean? Okay. So extreme programming is part of the agile software development method as well. And that means all code is written by two programmers sharing a computer, right? So, or a kind of pair programming. So what is the pair programming? Two persons working on the same thing, right? One is the person who is the driver who write the code, and the navigator just be like a person who review the code, check whether everything is right or not, okay? And normally, test cases are drawn, came up with by one of the team member as well, but testing is done by the other team member. Okay, so this kind of pair programming work, it will increase the quality of the software products as well. So this is one of the potential approach. The good thing is that when for example, the navigator can be a senior person and the driver can be a junior person, right? And then they can learn each other. It's about the knowledge exchange, sharing knowledge, learn how to develop a software together, which is good, but it is still costly, right? Because in this case, we need to hire like two people to work on the same thing, and it's not that cost effective in terms of the project management, okay? In terms of the budget, I would say, okay? So yeah, and the good thing for this part is that the knowledge is not lost when someone leave, okay? Think about the scenarios that we in the quiz before, right? When someone leave and then it's very hard for the team to get someone to work or continue working on the software product. But in this case, as I mentioned before, when we do the pair programming, then the knowledge is not lost at all. So when someone leaves, someone can be a backup person to step up and working on this one. Okay, and as I mentioned before as well, it is very good for when like a junior and a senior for junior software engineers to learn from the senior software engineers. Okay, and next we will talk about the Toyota. Okay, what is a Scrum and why Toyota use Scrum? Okay, yeah.
Toyota knows how to make cars. It does it so well, it became the first company to produce more than 10 million a year. Its success is rooted in a special system and began what's now known as lean manufacturing, an ethos emulated by companies around the world to make products faster, cheaper and better. Here's how Toyota changed the way we make things. Following the Second World War, Japan was left in a precarious economic position.
Steel and other metals are scarce.
Already disadvantaged by lacking natural resources, materials were hard to come by, and companies had to be creative to compete. Toyota's founder, Sekiichi Toyoda, had started a loom business, but it was his son Kiichiro who founded the motor company in 1937. They were used to working within narrow margins. As the shortage of materials increased during the war, the number of headlamps on its Model K truck was reduced to one, and it only had brakes on one of the axles. The turning point for Toyota's production system would come in the early 50s, when Kiichiro's cousin Eiji would travel to the US with a veteran loom machinist, Taiichi Ohno. They visited Ford's River Rouge plant in Michigan and were impressed by the scale of the operation, but knew that in cash-strapped Japan, companies didn't have the resources for such a system. Having months' worth of stock sitting in a warehouse would tie up precious capital they didn't have. Instead, what truly impressed Ohno was a visit to a supermarket, a Piggly Wiggly, according to legend. Japan didn't really have self-service stores at this point, and he was struck by the way customers could choose exactly what they wanted, when they wanted. He decided to model his production line on a similar idea. With the supermarket formula, only enough parts were produced in the first phase to replace what was used in the second, and so on. This is where the just-in-time system really took shape. Toyota was able to eliminate much of the waste in Ford's system, making smaller numbers of parts to be used when it needed them, allowing the company to operate on a tighter budget. As part of this, Ohno developed Kanban, a sign-based scheduling method which shows goods in production, and goods out. It's now seen as a precursor to barcodes. Ohno and Toyota also noticed that American car companies were still employing many of Henry Ford's early production techniques. They kept operations at full tilt in order to maximize efficiencies of scale, but then had to repair defective cars after they rolled off the line. Ohno believed this caused more problems and didn't encourage workers or machines to stop making the mistake. So he placed a cord above every station which any worker could pull to stop the entire assembly if they spotted a problem. The whole team would work on it to prevent it from happening again. As teams identified more problems, the number of errors began to drop dramatically. Combined with a culture of continuous incremental improvement called Kaizen, the Toyota production system built a brand known for making reliable and affordable cars. But Toyota was also getting good at producing cars quickly. In 1962, the company had produced 1 million vehicles. By 1972, they'd produced 10 million. It was around that time that the efficiencies of their factories enabled Toyota to produce a car every 1.6 man-hours, much lower than their competitors in the US, Sweden and Germany. And as the oil crises of the decade sent gas prices higher, cheap-to-run Japanese cars became much more appealing to Americans, whose powerful but gas-guzzling vehicles suddenly became very expensive to run. Today, Toyota has made over 250 million vehicles. Others have looked to them to learn the lessons of lean, combining craft with mass production, avoiding waste while striving for constant improvement. Boeing is perhaps the most famous, restructuring a plant to better suit TPS. Intel is another long-time lean ambassador and is exploring the principles in the context of AI and the Internet of Things. A Canadian hospital even used Toyota's system to decrease wait times in its ER. The Toyota production system changed not just how cars are made globally, but how we approach making things full stop. It also showed that there's always a better way to make a product.
Okay. So what do we learn from here, right? The Toyota. Okay, let me take a look. Okay, so I would mention about the Toyota a little bit, right? So basically, Toyota is the first who come up with it's called lean manufacturing. The goal of the lean manufacturing is to eliminate waste as much as possible in order to make the whole pipeline process, development pipeline process more effective and more efficient, right? So when you look at probably this figure, right? Let me try to get the pen annotate here, the zoom annotation. Okay, look at this one. Okay, so what does it mean? So Toyota adopt the lean manufacturing philosophy and also adopt the Kanban board. Okay, Kanban board. So if you remember in the previous slide, not sure, not previous week, probably week 2, we talked about the Kanban as well. Kanban, we focus on the flow of the tasks. Normally, it's a board, right? Let's say we have what is that? Backlog, doing, review, and done. Okay, and we talk about the flow of the tasks here. Okay, this is a task. The flow is in the backlog. This is in the backlog. Okay, it's not start yet. And what is that? In the next step, right? The backlog moves into the doing here, doing. So this is what they are doing, okay? They are focusing on this one and they review whether it works or not, right? Whether it works or not. If it doesn't work, everyone just like start fixing it, okay? Fixing this car rather than leave this car to the production line, right? So they fix on this one first and then when it is done, okay? When it is done, then let it ship, okay? This is how the Toyota adopt the lean manufacturing and use the Kanban board to keep track and manage the flows of the truck or the flow of the cars here. Okay, does that make sense, everyone? And based on the video, right? So what they found is that they can increase the revenue, they can produce more cars at the cheapest development cost as well. Okay, that's why they are successful nowadays. Okay, that's the Toyota things. Okay, and in terms of the Scrum teams, right? So basically that's a Kanban board, okay? Kanban. And now we're gonna talk about the Scrum, okay? Scrum basically we focus on the iteration, okay? Iteration. Everything is in the iteration. And normally the Scrum team has roughly 7 to 9 people, and different people have different roles. For example, a Scrum Master, Product Owner, Development Team. All right. So for the Scrum Master, basically their role is responsible for to facilitate the team to ensure that they follow the Scrum process. That's it. Nothing more than that. All right. Because not everyone is an expert in the process, right? So that's why sometimes we need a Scrum Master, especially the companies that they just adopt the Scrum process. Okay. So they need a Scrum Master to facilitate the process. But also we also need a product owner who is an expert in the business requirement, who is a representative of the client or the customer view. Just only one person is enough, right? And then the product owner will provide the direction or the what is that team? The roadmap for the development team. What we should do today, what should we do next, or that kind of thing. Okay. And the development team just a classic software engineers who develop the software products. Okay. Yeah. And in terms of the Scrum teams, right? Normally it is a fixed length. We adopt the agile method here. So we should deliver the working softwares rather than the documentation in a fixed length iteration. Normally one sprint or one iteration here can range between 2 to 4 weeks, okay, in a time box, okay? And yeah, we have the start, we have the end date. Within one sprint, we're gonna deliver something. That's the Scrum team, okay? And yeah, so what should we do here, right? What the Scrum teams do, okay? normally I'll try to get whether we have a better picture or not. Not here. Let me try to get this picture. 1 second. Okay. I'll put it here. That's how I develop the slide on the fly. Okay, maybe I'll put it here. Yeah, so this is the Scrum process, okay? In general, as I mentioned before, we have the product owner, we have the development team. Yeah, iterative approach. We have the Scrum Master who facilitate the Scrum process, right? And normally at the beginning of the software development process, at the beginning of the Scrum process, we need to do the product backlog. It means that we have a backlog here. We need to have the backlog item, write it down. What are the tasks that we need to do before we start? We need to do the sprint planning meeting, okay, to prioritize what are the tasks that we are going to focus for this sprint. Okay, so for example, we have 1, 2, 3, 4. Okay, 1, 2, 3, 4. But it seems that the task 4 is has the highest priority. We're gonna focus on the task 4 and the task 3, right? So when during the meeting, then we can finalize what are the tasks that we are going to do. So it's called sprint backlog. These are the backlog items for this sprint. Okay, so once we get the sprint backlog, then we can start the sprint. Okay, so the sprint can last between 1 to 4 weeks as well, and every day we can have a daily stand-up meeting as well to ensure that everyone is synced, that kind of thing. And the sprint review and the sprint retrospect. So once we complete the sprint, okay, then we should have a sprint review or a sprint retrospective as well to it's like a reflective session. We normally discuss what went well, what worked well in the past, what can be improved in the future, that kind of thing. And by the end of the sprint, we have to deliver something in a working software product. It's not just like something do not work at all, right? We need to deliver something, okay? That's the Scrum process. So we keep doing this each sprint, okay? On and on and on. Yeah. And once we do this kind of sprint, okay, so we can, if we use Jira, normally we can see the progress, track the progress as well. So it's called sprint burn down chart, all right? What does it mean here? I'm gonna explain the X and the Y axis, okay? So take a look at this one, the y-axis, okay, slowly together. Normally the y-axis are the numbers of story point that are remaining, okay, or whatever remaining at the beginning of the sprint. Let's say like in this case, we have draw here. We start the sprint with, let's say 28 story point. There are 28 story point that we need to complete, and over the numbers of days, how are they progressing? All right, so we can track the progress of our work as well, right? So once let's say 28 story point, but it doesn't mean that we have 28 tasks that we need to do. Some backlog item can have, let's say, 5 story point. Some backlog item can have 3 story point as well. Once it is completed, then it goes down like by that number, okay? So we can track the progress over the numbers of days here. And the yellow line, normally it reflects what are the actual remaining of the numbers of, the actual remaining of the story point, okay? But the ideal and the blue line also indicate the ideal case here, okay? Whether we are following the ideal case or not, and whether we are on track or not as well, right? Okay, yeah. with the use of the burn down chart, right? It is more transparent, so everyone can see the what they are doing and whether everything is going well or not as well. Okay, right. Oh, okay. Okay, here we go. Yeah, so does a scrum work most of the time or not, right? Probably not all the time. There's a pros and cons, and there are a few things that we need to consider as well. So normally, let's take a look at the picture on the right side here. There are 5 key values that for the scrum process, right? First, each individual should have a strong commitment. They have to be focused and they are open, they respect the team, and they are courage as well. So that means it means that the Scrum process, right, works well when each individual is self-organizing. What does it mean by self-organizing? I'm a person who is working in the Scrum team. I am so active and I can organize my day really well. These are the list in the backlog items, and this is the list of the backlog items. I know what I should do first and the last. Okay, this is self-organizing. I can manage myself really well. But when it does not work well, right? It does not work well when, let's say myself again, I am not a well-organizing person. These are the tasks that I need to do, but I still don't know what should I do first, right? This seems to be the task that has the highest priority, but I'm so scared why this task is so difficult. Oh, I'm so scared. I'm so afraid. I don't know how to implement, how to work on it. So with this kind of scenarios, the Scrum process will not work at all. Okay, so that's why let's move to the next bullet point, right? The Scrum process will work well with someone who have more experience, who is self-motivated, who is self-organizing, and is a full-time developers as well. It might not work well for the part-time. For example, these are the backlogs that I need to complete, but I'm working part-time. I need to start working from 6 p.m. All right, so nothing will happen during the day, but it will happen during the night. So maybe it may not work in most of the cases, but they work in some cases as well. Okay. Yeah. Okay. All right. And when because the Scrum probably it's quite new to some of the software companies, right? Probably sometimes a workshop is needed as well. That means we can have a agile consultation or agile expert, right, to come to the company, and they can facilitate the workshop, try to simulate. This is try to simulate how the Scrum works in a simulation setting, that kind of thing, before the software companies you adopt the Scrum at the full speed. Okay. What else? Yeah, teamwork in the agile process. Again, when we talk about the agile, right, it's the whole team responsibility. I cannot emphasize enough. What does it mean by the whole team responsibility? It means that when we deliver the quality, when we deliver the software products, right, the quality is the whole team responsibility. Everyone should write the code and test the program. The quality of the program should not be the sole responsibility to the software tester or the QA teams at all. That's more towards the QA process, right? So everyone should have the quality aspect in your mind. And what is that? Normally we will focus on try to do little things. Oh my goodness. Okay, the pen. Okay, normally we should focus on how to do little thing, everything all the time, right? So that's why we should incrementally and iteratively deliver the working software products. Working, it should be working. It may not be completed, but it should be working, right? Otherwise, if we focus on if we implement everything, all of the unit, all of the methods are fully implemented, but probably when we do the integration testing, it may not work, right? And it's hard to debug or to find out which part of the software system that is broken. That's why Agile incrementally deliver the working software product is a key thing here, and it is very, very important in real world scenarios. Okay, all right. Yeah, we focus on the collaboration through the commitment. Yeah, so we will have the shared goal. The shared goal means that when we do the go back to this one to here, right? So the sprint backlog, that's a shared goal. Okay, one sprint. This is the things that we need to complete. Everyone understand. Everyone's clear. Let's get it done throughout the sprint, and then we can deliver it. That's how we do in a more agile way, right? Okay. Successful chain is not entirely okay. What are the things here? What is this? There are two styles, right? Top down or the bottom up. Okay, let's try to understand this one together. Top down, it means that the organization follows the leader, CEO, towards the vision. CEO just said, okay, we need a Twitter. All right, and every software engineer just need to like develop the Twitter, social media platform, that kind of thing, deliver it, right? So it's not flat at all. It's more like a hierarchical style, working style. But when we talk about the bottom up, that means the organization is very flat. And it doesn't mean that the CEO has any power. Probably it's about the communication. Everyone is agree on the same thing, right? And it doesn't mean that the senior engineers has more power than the junior engineers. So that's why working style with the bottom up might be better as well, right? Okay, because the decision is not go up to the CEO at all. And right now, the individuals can decide as well what needs to be changed, what to do, because and then the team is more, how can I say, autonomous, okay, self-autonomous rather than the like a top-down style. Okay. Okay. I think that's all. Yeah. The end state is unpredictable. Yep. So change, we need to adopt the change. Change is unpredictable, and we cannot avoid that as well. We are talking about the continuous improvement. How can we adopt the change over the time period, over the process, right? So that's why when we use the agile, every iteration we have some gaps to change something as well. So that's why agile is more common and more is more commonly used in the modern software organization nowadays. Okay. Any questions so far? Okay, Scrum is dramatically different. Many of the changes go against much of the past training. See example here, right? So what is this? Okay, first, traditional. Oh. Next time I should get a pen. Draw. Traditionally, a programmer has been trained that a problem is to be analyzed in depth and a perfect solution designed before any coding begins, right? But when we do the Scrum, okay, what does it mean? Normally, we will not expect everything to be perfect, okay? And says a fully considered design is not always necessary. Yeah, we will focus on the working products rather than the documentation. And this is more like a traditional style, what's that, waterfall, right? Traditionally, a tester has learned that their job is testing for compliance to a specification. But when we talk about the Scrum, it's about whether whether the software that we develop meets the user requirement or not, whether meets their need or not, right? So it's about mindset, okay? It's about mindset. Yeah, so it is different from the waterfall process. Okay, any questions so far? Before I move on. Probably no, then maybe I will move on. Okay. And I would say that in real world scenarios, right? This is whatever happened in the book, okay? This is the book in the practice, in the theory, but every organization may have different variants of the Scrum process as well. And it is not necessary that every companies have to follow this, like strictly follow this Scrum process, right? They can over time, we can talk about the continuous, and we can talk about the process improvement as well. And they can do some minor change into the process as well, right? Think about, let me put this way. I had a discussion with the Monash solution as well. They would use the agile software development process, but because they use the tool-based agile, right? For example, the Jira issue tracking system, the process may not be strictly aligned with the Scrum, but still share some common things together, right? So probably in the next few weeks, maybe I should invite some person from the Monash solution to talk about what are they doing and what is the process behind as well. Would that work, everyone? Yeah. Okay, the last thing, right? The last thing, the last part of the how to work as a team, right? Open source software team. Okay, open source software projects. I'm pretty sure that at least one of you should have used some of these open source software projects before. For example, Linux, it is part of the operating system kernel in the Mac, Apple Macintosh, or MySQL, that's a database. Mozilla Firefox, that's a web browser. Android is a mobile phone, right? Operating system. Java, everyone implement Java before. That's an open source software system as well. Okay, a few of them, I'm sure everyone knows it. But I think this is something that is really surprised, right? Open source software is really voluntary based. No one get money. It is unpaid. When they are working, they contribute as a volunteer. As a contributor, the communication is in a asynchronous style. That means the open source software developers can come from anywhere in the world. They don't need any like meeting. They can work asynchronously, and they can work effectively as well. They don't have the team meeting, unlike software companies that with the full-time employees, right? And they don't have managers. Sometimes the specification is documented somewhere, but it's not like a lengthy, like a waterfall style, that kind of thing. How can they work together? That is so surprised, and that's like a magic to me, right? So okay, let's discuss together as well. Okay, so the next bullet: why have small numbers of open source software projects attain high level of success? So yeah, that's a good question as well, right? So the open source software project is successful because they talk about the I would say that it's about the values of the software products. They believe in something that why that let's say collaborative work means or has more values than like a company style, right? So think about the operating software system, Linux. It was created by Linus Torvalds in a few decades ago, right? But it's still used nowadays, okay? But there are different variations, and the Android is also part of them as well, right? So the good thing is that they can modify. I think we should talk about the software license as well, but that's another topic. But what I want to say here is that open source software projects, when you develop, you can contribute to it, right? And then you can create a variation, and without asking for the permission, and you don't need to deal with the patent, that kind of thing as well. So everything is free, everything is open source, you can access to it, you can customize it. That's why people love the open source software projects so much, right? And because the projects, the code base is open source, everyone can contribute to it, and then we don't need to force or ask someone like, hey, look, why don't you fix it? Why don't you fix this? We can create the issue, and whoever have time, right, they can also fix on it as well. Okay, that's the open source software projects. Any questions so far before I move on to the unified software process? Okay, nope, I will move on to the unified process. Okay, unified process, what is that, right? It's a mix. I would say it's a hybrid. It is very hybrid. It's a hybrid between Agile and the waterfall, right? So it is very useful, and people often use it as well. We don't need to be strict on the waterfall. We don't need to be super Agile when using the Agile, but we can do something more hybrid. So it's called unified process. Okay, so just a recap as well. When we talk about the iteration, this is the iteration in the Agile software process. We produce a working software products for each iteration, iteratively, incrementally, keep improving it, right, for each iteration. Yeah, but when we do the Agile, okay, we normally have the design, build, and test. This is like a classic life cycle in the Agile for each iteration. But when we do the but in reality, right? So because we need to adapt change, sometimes requirements are changed during the software development. How can we fix that? And at the end of the day, we need to include that requirement and change it anyway, right? So that's why we probably can move the waterfall into more an iteration and increment as well. So that's why instead of having iteration, this one, right? Like Agile, we can put the mini waterfall here, requirement, design, implement, and test into an iteration, and keep incremental working on it, okay? Yeah, we can do like that as well. This is what happened in practice, right? So that's why in the unified software process, they in the book, okay, in theory, they said that we should produce 4 increment. Okay, 4 increment. That's a 4 iteration here, 4 increment, and each increment, okay, we have 4 increment. Okay, for each increment, we can focus on these activities. Okay, so that means in the first increment, we will focus more on the requirement. We will focus more on the analysis, but not much on the design and the implementation. Once everything is clear, and we can start working on the acceptance test scenarios as well, right? Test the requirement, otherwise validate the requirement, whether it is right or not, and it is implementable or not. Once we complete the week 1 to the week 4, the first increment here, moving to the next increment, we will work less on the requirement analysis, but we will focus more on how to refine the requirement, make sure that it is clear, it is concise, it is testable, it is implementable, and then refine the analysis, refine the design, and we will start the implementation process, right? Once over time, right? Over time, when the requirement is stable, and then we will in the next increment, we will focus less on the requirement change anyway. And then, but analysis can be modified, it can be refined along with the design and the implementation together. Okay, does that make sense? Once we implement something, we may need to refine the analysis, refine the design as well to understand whether it works or not, what went well, or what can be improved in the future. Okay, and later on, before we deliver the software testing in the last increment, okay, of course, requirement should be like a less requirement change now. So we avoid, normally we will not touch the requirement in the last stage of the software development. Okay, but we will focus on more on the fixing the code, make sure that it is functionally correct, it is functionally complete, and it is well tested as well before we deliver the software product to the end user. Okay, makes sense here. That's the incremental unified software process. Okay. Okay, and normally we can compute the effort, right? Because I already explained everything. Normally the gray area here is the effort that we're gonna put into each phase or each increment. Okay, so that's I already mentioned before. Yeah. We will not say this is the phase. Okay, it's called workflow. Increment, in one increment, there are 5 workflow that we need to do. We will start like this. Okay, it's not the phase at all. Okay, and then we keep moving to the next iteration and iteration. It's a mini waterfall in each increment. Okay, does that make any sense here? Do you have any questions? All right. So the key question is that what activities are not shown here? There are a few things missing, right? So this is more like a workflow. It is high level, it is in general, but sometimes it's not include everything. For example, when we analyze the requirement, what do we need to do? Document the requirement, that kind of thing. So there are a few activities that are missing here as well. For example, documentation or other things, right? So that's why we can modify and change it as well. Okay. And the unified process here, right? So this is more like a terminology, all right? What is the difference between iterations and the increment? Okay. So normally we start one increment. It means that we start from nothing. One increment should deliver something incremental. All right. So we should deliver something. Within one increment here, there are 5 workflows that we need to do. And each workflow can be in each iteration as well, right? So that means, let's say one increment is 1 month, okay? 1 month. And each increment can have, let's say, 4 iterations. 4 iterations, 4 iterations. And each iteration can be 1 week. That means this is how we organize the work in the team, right? The first week, probably we will focus on the requirement, okay? The second week, we will focus on the analysis. And the third week, we will focus on the design. And the last week, maybe we will focus on the implement and the testing, something like that, okay? This is the difference between what is an increment, what is an iteration, and the workflow. Does that make sense? Okay. When we, as I mentioned before, it's more like a mini waterfall process, right? And yeah, normally we will start from, what is this? Let me try to get the pen again. Okay. So when we say increment A, B, C, D, right? In the unified process, they can name it as well. That means that during the first increment, normally it's called the inception phase, okay? Inception phase, that one, and they try to perceive, try to understand what is the requirement, and during the next one, it can be during the elaboration phase, because the first requirement, it may be not clear. During the next increment, we can elaborate the requirement more from the customer as well, or from the end users. So we're gonna refine it, and we're gonna construction it, and then we're gonna transit is the transition phase. We're gonna deliver it to the end users. Okay. Yeah, that's what happened in the mini waterfall. Yeah, no, sorry, in the unified process. There are some advantages and some disadvantages here as well, right? So the good thing for this is that it allows it provide opportunities to fix something, refine something, modify, keep improving it, adapt the change, or that kind of thing, right? And yeah, the risks are mitigated early as well, because in the during the inception phase, we just elicit the requirement, but once we try to design the structure or architecture of the software system, right, we may come up with some issues, right? And then we can elaborate further with the customer as well. Oh, this detail is missing. What are these? What do they want? And then we can refine the design, the architecture, and the implementation as well to align that need. Okay. All right. That's all. I think in general, that's this is pretty straightforward, right? Okay. And then during the what is that here? OO paradigm. When we use the unified process, right? We may need to use the UML diagram as well. Okay. During the design process. Okay. During the what is that? Design and the analysis workflow here. All right. So what is a UML? We talked about that before as well. UML is a standard modeling language, and that's why when we do the UML diagram, we can adapt the unified process as well. So it will not be perfect at the first iteration, but we can keep improving it, right? Modify, refine the UML diagram over time until it is satisfactory. Okay. All right. Next, we're gonna talk about each workflow in the unified process here. Okay. This one. All right. There's a mini waterfall here. So in the first iteration, oh, sorry, in the first increment, it's called, what is that, elaboration, right? Think about building a house. Normally, the designer will come back to the client, like let's say myself, right? Let's say I want to build a house. I would tell them, okay, I need 3 bedrooms, 2 bathrooms, and 2 garage, 2 car, that kind of thing. So that's kind of like we elicit the requirement. We want to get the requirement from the end users. And this is what happened in this part as well. And once we elicit the requirement, as we mentioned before in the previous week as well, we need to use the UML diagram to describe the client business need, okay, and the process as well. And if anytime the client does not feel that the cost is justified, then we can stop doing the development immediately as well. So when we elicit the requirement, there are a few things that we need to consider here. Of course, what is the deadline? Okay, do you need the software by today or by tomorrow? Probably that is not realistic, right? But we need to understand first, what is the requirement? What do they want? This is and how large it is, right? And then we can understand their expectation as well, whether this is going to be like a 1-year project or 8-month project or 6-month project, half a year. So we need to get the deadline. We may need to understand if there are something running in parallel or not as well. what's that? There are other things that we need to consider, right? Whether the system should have some portability capability as well or not. It can run on any it is cross devices compatibility. It is reliable. What is the response time? For example, the website can handle a million load requests, okay, in 1 second without any downtime, that kind of thing. And of course, what is the budget in mind? This is a classic, right? Classic question. What is your budget in mind? We need a Twitter software project in $1. Probably that is not impossible. Yeah. So that is impossible, right? So we need to make it clear and manage the right expectation with the client as well. Once we do finish the requirements workflow, right, then we can analyze the software. Once we get the requirement, we need to analyze the requirement and refine it. We need to translate from business language into a more like a development language or something that is understandable as well. For example, probably the first requirement that we may get, okay, I want to increase the profit for an online e-commerce system. But how, right? Then we need to elaborate a little bit, dive into the deeper specific requirement. Oh, we can increase the profits for the e-commerce system by implementing the product recommendation before the checkout feature, before the customer use the checkout, okay, before they check out. That kind of product recommendation, this is something that is, when we write the requirement, it must be implementable, it must be testable. When we say we want to increase the revenue, that's not the functional requirement at all. And it's not even be the requirement, okay? It's the business requirement, but it's not the software requirement. Yeah. And of course, it should be written or expressed in a plain language, right? This is very important. But sometimes the natural language or human language are imprecise as well. For example, what would be a good example here? Let me think. Imprecise. For example, in the online e-commerce system again, right? The system should when a user search for a product, the system should present at least 10 items, 10 relevant items, at least 10, right? At least 10. And then what is the boundary here? Can we present like 100? Okay, can we list like 100 products in the online shopping system? Probably it's unclear. That's the imprecise, right? Okay, does that make sense, everyone? Okay, next, the analysis workflow example from so for this one, let's take a look at this example together. A part record and a plan record are rated from the database. If it contains the letter A directly followed by the letter Q, then calculate the cost of transporting the part to that plant. Okay, this is more like an example in the manufacturing system, in the manufacture. Okay, in a warehouse. All right, so, but we understand, do we understand this or not, right? What is a part? What is a plan? I have no idea. And what is a database? I have no idea as well. Even I read it, right? I start to get confused now. So that's why we should make it clear when we write the requirement analysis, when we write the requirement to the developers, right? Yeah, it should be expressed in the language of the client, and it should be precise, and it should be complete for the designer as well. Right now, it's unclear. What is a part, what is a plan, and what is that database as well, okay? Yep, when we talk about the software project management, it's about planning, managing things. And we often focus on the three aspects here: the time, the cost, and the quality, Okay, we normally manage these three key aspects. Okay, so these are the three key important. And to do this, okay, during the planning process, there are a few things that we need to write it down as well. For example, what is the budget? What is the cost? This is what we mentioned before as well. How long does it take to develop the software products? What are the deliverables? Are we going to deliver just only the software or the source code as well? What is the milestone? What is the timeline, right? Is it like just one-off milestone? Okay. We listed the requirement today. See you again next year. Probably it doesn't work at all, right? If we use like an incremental software development, probably we should release a working software products over like as an incremental things, right? As an increment, probably like monthly, that kind of thing. And what is the budget? What is the payment period as well? It's like a one-off payment. Pay now 100%, get something else next year. Probably it won't work as well. Normally, when we do this kind of software development projects, it will be like a incremental payment as well. Finish the requirement, pay 10%, design and that kind of thing, another 10%, 20% or whatever, right? Okay. That's what we do in the project management plan. And it is also part of the analysis workflow as well, okay? And when we do the design, okay, so we will refine the analysis now. We will use, again, what is that, UML diagrams, decide the class, decide the structure of the software system, understand the workflow, understand the usage scenarios, what is the use case diagram, that kind of thing, right? And this is what we do during the design, and then we implement it. And we will talk about the clean code later as well. It's not just write something, implement something, but it should be it should be readable, it should be maintainable, someone can extend it as well, extensible, that kind of thing. There are other quality attributes about code quality that we need to consider as well. Everything must be traceable. Okay, we have requirement A. We draw some class diagram. Okay, we draw it, and then we implement something, but nothing is traceable. How can we ensure that whatever we develop actually meets the requirement, right? So that's why traceability metrics might be helpful here. And sometimes, I don't know whether we have here or not. Yeah. No, okay. So, and examples of the, okay. Go back. Draw. Okay, I got the pen now. Yeah, so sometimes people call, or you can Google later as well, right? It's called requirement traceability matrix, okay? In the requirement, we can break it down into the requirement ID, okay? ID. What is the requirement ID? What is the requirement description? Okay. And what is the acceptance scenario? How can we test this kind of requirement to ensure that the requirement is met, right? What are the steps to test acceptance test scenarios? Oh, we mentioned before. We can, we actually should have this one as well, okay? User stories. So that is very important in a short description, right? As something, I want to blah, 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 so that what are the values and the benefit? Okay, we have the user story, we have the acceptance criteria. If this acceptance criteria, we can it can be associated with multiple functions as well, or multiple methods in the file, right? And each of them, we can come up with the test case as well. This is like a test case ID. When we do the test case, normally it goes to the unit testing or the integration testing, right? Come up with the test case, write the test case, and test it whether this functional requirement here is met or not, right? And then we can tick the box. Okay, when everything is tested here and it is related to the test case ID 1, 2, 3, 4 or whatever, then we can confirm that, confidently say that this requirement is met. And when the others are not tested, then it's not, right? This is how we check whether we can deliver the right software products or not. And traceability is one of the most important technique to use in the software development, Okay. Questions? Nope. Once we develop everything is traceable, then we can move to the test workflow, right? And there are 4 levels of the software testing as well. As I mentioned in the previous slide, we talk about the unit testing, we talk about the user acceptance testing, right? When we talk about the unit testing, when we write the software, there are different classes, there are different functions, and the unit testing just want to test the smallest component as much as possible, right? And each unit should be independent with each other as well. For example, this is a let's say we're gonna implement a calculator application, okay? Calculator. Let me draw a calculator, okay? Calculator, draw, get a pen. All right. This is a calculator app written in either Java or Python, whatever. We have the numbers here, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have the operation plus, minus, multiply, subtract, divide, or whatever. So that means the unit testing here, normally we would test the operation here, right? Whether the plus, the summation, the minus, the multiply, the divide works correctly or not based on A or B input, 1 or 2 input or whatever, right? So that's the unit testing. But when we do the integration testing, it means that we want to combine multiple components to test with each other. So it's going to be a series of the operation now. For example, 1 plus 2 plus 3 plus 4 plus 5. Okay, that's how my son challenged me. Okay, what is the result for that, right? That's the integration testing. Yeah, surprisingly, my son do the integration testing to me every day. Okay, so that's how they test the calculator app. Okay, and once the integration test, all of the components are combined and tested, we want to make sure as well, okay? We need to do the system testing to ensure whether when the product appears to be completed and it is tested as a whole. As a whole, when we do integration here, right? So in this case, probably how can I say, integration, we can also write a test case that tests a series of operations here, blah, 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 okay? But when we do the system testing, we may need to ensure that every button is workable as well. It's not just only operation here. And the user acceptance testing, that's more of the UI now, okay? So you need to press the button, okay, click this, and do this, do that, okay? But the user acceptance testing can be automated as well. For example, you can use like a Selenium, that's for like a UI web browser testing, or you can use what is that, Monkey something for the Android. Okay, Android. Yeah. Okay, that's the 4 levels of testing. All right, I think anything else? That's a recall of the iteration inception phase, right? So once we finish the test workflow in the first increment, then we can move on to the elaboration phase, elicit more requirement as well, refine it as I mentioned before, and then we construct the software, and then we deliver it to the end users, to the customers, okay? What is the difference between the waterfall and the agile, right? Waterfall basically is like it works as a phase. It has only one dimension. Agile, it also has only one dimension as well. We talk about the phase increment, okay? Like that. Unified process is more like a 2 dimension, okay? So each in the unified process, right? It has each increment or each phase here. Start with the inception phase, elaboration phase, construction, and transition. Each of the phase has 4 or 5 workflow here. Should be test as well, okay? Test workflow here. And within the phase, it can have multiple iteration as well, okay? Does that make sense, everyone? Okay, I hope all makes sense and all clear. All right. But the key question is that why do we need the two-dimensional model here, right? That is more like the reality, right? Because we need to adapt to change. Change can requirement change can happen most of the time as well. And when we use the two-dimension here, it means that we break things down into the smallest tasks. All right, and we have some guideline to perform to action as well. When we do the agile, right, we just talk about what is that? Let's say we use the Scrum process, right? We have the backlog sprint. We have the item backlog here. We have the sprint backlog. After the meeting, we have the sprint backlog. These are the things that we need to do. But this is more about the actions, okay? Just only doing, implement things. But what about the requirement? Does it fit within the iteration or not? Probably no, right? It's unclear here. So that's why unified process is a hybrid version between the waterfall and the agile. That's why we should also use it within the unit as well. Okay. I think this is agile. Okay, just a recap. Okay, let's take a look at this video together. What is the Scrum again? All right.
Suppose you'd like to start a new project. Usually you'd draw up a plan, make a schedule, find a project manager, hold endless meetings, and ultimately just hope you don't stumble before you reach the finish line. But what does that usually deliver? Everything's more expensive than expected. You stress about your deadline. The end result could have been better, and energy has drained from your team. These problems are solved with Scrum. With Scrum, you write fewer plans and you do more. In short cycles, we call sprints. You don't work on separate islands, but as one dedicated team. Instead of working on a project with a distant deadline, you constantly deliver functioning products. You don't use final evaluations, but you receive continuous feedback. Scrum is a flexible way of working in a rapidly changing world. It's frequently used in IT projects, so many of the websites you visit or apps you use were made using Scrum. This way of working is used more and more. Scrum was recently used to build a large new bridge. But it can also be used to develop new products, compile budgets and annual reports, organize events in your town, or even to set up a completely new company. How does Scrum work? Let's use the marketing campaign for a new car as an example. In the first week, you take action right away. You share a glimpse of your design through social media. The feedback you receive will be used in week 2. You attract media attention, which leads to new feedback for making improvements. We call these weeks sprints, which are actually mini projects that each produce their own specific results. Instead of knowing exactly where you want to end up, you take a step-by-step approach as you work towards your final ambition, like the successful launch of a new car. A Scrum team has stand-up meetings, works transparently, feels a joint responsibility, is aware of the progress made every day, and has results to celebrate after each sprint. Scrum has 3 roles. First, the product owner, the key stakeholder with a vision who provides direction to the team for each sprint. Then there are team members, 5 to 9 professionals in various disciplines who are jointly responsible for the results. The Scrum Master, a facilitator who focuses completely on the process. Then there are Scrum lists. The product backlog, in which you list your ambitions and express how you intend to achieve them. The sprint backlog, the shopping list of products you want to produce in the next sprint. The definition of done indicates precisely what needs to be done by the end of the sprint. And the Scrum board, This shows all of the team members' tasks, which will change from to do to busy to done during a sprint. Then there are 4 meetings. First, the sprint planning meeting. What exactly are we going to achieve during this sprint, and who's doing what? Next, the stand-up. Is everything going according to plan, and are we going to make it? The third meeting is the review, during which you deliver your results and receive feedback. The last meeting is the retrospective. You look back on the process and reflect on what you can improve as a team for the next sprint. Scrum is a powerful way of working that provides speed and energy. Maybe something for your organization too?
Okay, thank you. Okay, Scrum, good for your, what is that? Speed and energy. Clear. Okay, I think there are a few things that we need to cover. We talk about the Scrum already, Kanban. Okay, so I hope everyone is clear on this. Okay, Scrum focus on the iteration, the working software products. We want to deliver the working software products incrementally over the sprint. Okay, but the Kanban focus on the flow of the tasks. Okay, whether it is in the to-do stage, in progress, testing, and done, that kind of thing. Okay, the focus is different. There are some benefits for the Scrum, right? Because shorter cycle, it can shorten the cycle times, and then we can deliver the software feature faster as well. It is responsive to change. When prioritize the change frequently, Kanban is ideal, and we can balance the balancing demand against throughput guarantees that most of the customer-centric features are always being worked as well. So there are some benefits about the Kanban, but I think in general here, reducing waste as well. This is the same as the lean manufacturing that I showed the video before, right? So these are the benefits of the Kanban, okay? And I think we talked about the Kanban before, how to use it. It is a column, okay, 4 columns, probably. It can be, let's say, to do in progress or working, testing, and done, right? And then we just keep track the flow of the tasks. And then, yeah, I think I explained everything already. Okay. Yeah. So maybe go to the quiz. The quiz, maybe let me take a look at the quiz. All right. Okay, any other questions so far? I think backlog I have already mentioned as well. Backlog has we need to prioritize it as well during the sprint planning. Which one has a higher priority or that kind of thing, right? Okay. Yeah, we talk about the burn down chart already as well. And in Agile, what is the best definitions of the backlog? Okay, that's the next question. Okay, maybe I'll move on. Okay. I already talked a lot about the waterfall, Agile, Scrum, Kanban, unified process. I think let's move on to the next topic. Okay, version control system. Why? Why do we need version control system? And surprisingly, based on my experience as a teacher, right? It seems that students are struggle a lot when using the version control system, GitHub, Bitbucket, or GitLab, or whatever, this kind of thing. Okay, what is that? We're gonna, I encourage everyone to be a master on using version control system so we can collaborate. do the coding collaboration with the other team members effectively. Okay, so VCS or version control system, it is a system to keep track the version of the piece of source code in a more version, right? Incremental version, one commit, one version, one commit, one version. And yeah, because of this, it can help us, the software team, manage the change to the source code over time. Think about the previous style, okay? We use the what is that? Microsoft Word. You write an essay, something, okay, and then tomorrow you keep improving it. You delete something, and then you cannot go back to it at all because we didn't keep track the change. Okay, one simple approach that people normally use to copy and paste. Okay, copy the first version, create a new version, and then underscore V1, V2, V3. This is a classic traditional style how people keep the versioning of an artifact, right? But it's not effective at all because when we develop the software, we can have like 1,000 versions, 1,000 change, right? So that's why we need a more effective approach to manage the version of the software or the code base here. That's why we use the version control system. And the classic one, okay, I'm not going to talk about the traditional style like what is that, SVN, Mercury, CVS. That's old style already. Right now, people only use Git. Git is a distributed version control system. What does it mean? I will just provide you the background a little bit, okay? Traditionally, SVN, right? This is a one repository at the server, okay? People clone and then keep improving it or whatever, and then merge into the main repository. This is SVN. But when we have the Git version control system, this is Git, all right? Git has a master repository at the remote server, here, okay? Let's say GitLab or GitHub, whatever. And then they keep track their own version as well. They have the timeline, okay? For us, we normally need to clone into our local repository, okay? Keep track, working on something. The code that we change, it will not impact the main repository at all until we push and merge it into the main repository, right? So then the code, whatever we write here, in the local repository or in your laptop will appear in the remote server. Okay, that's how the Git works. Okay, that means when we change, this is what happened in the remote server. Okay, GitLab, GitHub, whatever, and this is what happened in the local repository in our laptop. When we change things, it will not break the main repo. Okay. Different from the SVN or the traditional style version control system, we need to put everything into the remote server only. We cannot keep the backup or the version in our local repository at all. That's why Git is called distributed version control system. It is distributed. There's a repo in the remote. There's a repo in the local, and there's a repo in your friend as well, your friend laptop, and another repo in probably like the tutor's laptop as well, right? It is distributed. The version may not be the same until we sync it, okay? All right, version control system. Okay, using Git is part of the use of tools assessment as well. So try to, please make sure that you know how to use Git. Okay, you can learn from Google as well. Don't forget a short video to explain all necessary features of Git is available in Moodle. Okay, please check in Moodle as well. Yep, these are the typical workflow in the version control system, I would say, for Git. Okay, Git, normally these are the steps that you need to do. Okay, first, you need to commit a change. What are the files that you want to change? You commit it. When you commit it, it only appears in your repository, okay, in your local repository. But once you want to make a change to the remote server, then normally we use the push command, okay, to push your code in the local repository to the remote repository, all right? But just in case that maybe because this is distributed, your friends may update some code as well, and then they push to the remote repository, but we are not up to date yet. Okay, to update the version from the remote server, we need to pull it back. Okay, pull the code from the remote repository to our local repository. All right, this is the three commonly used commands in Git: commit, push, pull. If no one, please try to get familiar with this command as well. And normally when you want to modify the code, it is best to create a branch. Okay, when you create a repository, you can create a new branch as well. Master is the masterpiece. We want to make sure that master branch works all the time. We should not break it. But when you want to modify something, you create a new branch, working on it until it is well tested, it is ready to be merged, and it does not break the other people code as well. Then you can merge, okay, merge your branch into the master repository. But sometimes when two people modify the file, when two people modify the same file, right? There may be some merge conflict as well. So we need to find a way to handle the merge conflict as well. There are lots of tools available at the moment. Like Git can be used as a command line, can be used as a desktop tool as well. Maybe you can just Google to find out, or it is integrated in the modern IDE as well. For example, VS Code or PyCharm. I think everyone will can learn from that as well. Yeah. Okay. All right. Yeah. In summary, so in this lecture, we talk about team. We talk about unified process. We talk about the Agile. We talk about the Scrum. We talk about the Kanban. We talk about the version control system. Okay. And if you have any questions, yeah, feel free to post on the ED STEM as well. Or otherwise, thank you so much, everyone, for your attention, and have a good day. See you next week.